Welcome everyone to this Ask Me Anything session, and today we are going to talk about security and open source health. My name is Hugo Schonewille. I will be your host today. I'm a customer success manager at Sigrid here in Amsterdam, and with me together is Jan Laan, who is the senior security consultant. He'll do most of the talking of the session today. I'll just guide you through it and hopefully answer some of your questions and guide them through Jan. We're going to talk about security and open source health today, and what we're going to talk about are things that are in line with what Sigrid can do for you. So Sigrid helps you, for example, with a unified oversight in the security of your IT portfolio. Unified is the highlighted part. It's the part where Sigrid brings everything together for you. It's about continuous scanning and vulnerability management. I highlighted continuous. Again, I did that because Sigrid is not there just to scan at the end. It's not there just to scan at the beginning, but to do your entire security management process and vulnerability management process using the platform. It then helps you to prioritize your risks and create some strategies and mitigation strategies around that. And last but not least, it is also monitoring not only your security of your self-developed code, but also the code that you include from the open source market. So all of these four things we will be covering, and by we, I mean my colleague Jan, who's going to take over the screen and tell you more about this.
All right, so a little bit about Sigrid security and open source health. So if you're a Sigrid user, then you're probably well familiar with our maintainability offering, code quality. But Sigrid also has these security models that we'll be discussing today. So specifically, we'll be discussing two Sigrid modules, one called open source health. So open source health is really about third-party open source code in open source libraries that you use in your system. So that is code that you have not written yourself, but there are libraries that you import. And then Sigrid software security, that goes onto the security of your own code. So security issues that may appear in code that you've written yourself. So Sigrid can help you identify these kind of issues in your open source or your code base, and so that you can resolve them so they won't be any security risk. What we also offer as SIG is down in the bottom, even more in-depth security advice, which is outside of Sigrid, but it's a more in-depth analysis. We call this a focus inspection or a deep dive. If you need more help, more guidance, we also offer that. Just reach out to us separately. For now, we'll be discussing these two modules. Let's start with open source health.
Before we continue, sorry, Jan, one more thing which I forgot to mention. This is called an Ask Me Anything session, and I would like you to if you have any questions, please drop them in the Q&A section or in the chat. We'll be answering the questions while we're going along, whenever it fits. So please do feel free to ask your questions. So Jan, please do continue.
So I will give a brief intro. What is open source health? Why do we care? Then I will walk you through how would I use Sigrid's open source health module as a user, and then we'll see what kind of questions you have, and then we'll do the same for the security module.
All right. So the first question already came in, by the way, Jan. Maybe that's a thing, yes, that you can answer. I think along the way. What is the overlap, or is there an overlap between maintainability and software security? I think that's something that we can weave into the explanations.
Yeah, sure. Let me tackle that actually straight away. So maintainability is really about it's code quality, right? It impacts it's internal to your organization, right? Higher maintainability makes you have less bugs, makes you produce new features faster. But security is really it's external, right? It's external exposure. It's when you get hacked or not. So they are related, right? If your software is more maintainable, then it's easier to fix security issues. But that's the extent of the relationship. So open source health. So why do we care? You may have heard of this term called SBOM. What's that all about? Why do we care about open source health? So this is a topic that's gained a lot more attention in the last few years. But why? Well, there's a few reasons. One reason is security. So there are many security issues identified in open source software packages every year. Last year, this was almost 29,000 individual issues, and this number is increasing rapidly every year. And if you are an attacker, exploiting these open source issues is very appealing because a popular open source package is used millions of times. So if you find an exploit in open source, you may be able to exploit thousands of systems at once instead of just one. So it's very effective for an attacker. Yeah. So you don't want to get hacked. So you want to do something about the security issues. What also comes with open source is potential legal issues. Most open source packages come with a specific license, and that license says, as a author, I provide this open source package, and this is what you can and cannot do with this package. And sometimes that puts restrictions on commercial use. And if you then use this software commercially, which you're not supposed to do, could lead to fines. Just an example, last week, a large French telecom organization was actually fined 860,000 euros for violating one of these open source licenses called the GPL. So it is, I will have to admit, it's rare that these fines actually occur, but it does happen. And lastly, there's also compliance. Sometimes there's just regulations, a law that says you have to. If you're in the US, there's a specific executive order that says you have to keep track of your open source. If you're in the EU, same thing. There's a regulation coming up that says you have to keep track of your open source. If you're in the payments industry specifically, there's also a regulation that says you have to. And if so, there is no choice. You have to comply with the law, right? Okay. So now we know that we care about open source, that we need to keep it in shape. So let's see how Sigrid helps us there.
So now we're going to switch to Sigrid, and we're going to see what it looks like in Sigrid, what things Sigrid helps you with to show you the open source health risks and how you can prioritize findings that come from there.
Yes.
Am I right?
Here we are. I have opened Sigrid on one of my favorite systems. So the system is called Hadoop, and it is my favorite because it has issues. Let's explore. So this is the overview phase. I have defined a few objectives. For example, here in this table, you can see for open source, I don't want license issues, except for low risk license issues is fine, but any other I don't want. And you can see there's a gold cup, so I've actually achieved that objective. So in terms of legal license, I'm good, but in terms of, for example, open source vulnerability, I have a gray cup. I don't want the gray cup, I want a gold cup. So there's issues there. So let's explore. If we go to open source health module in Sigrid for this system, I see, okay, there's 47 open source libraries, that's fine. And then it says immediately here, libraries of vulnerability risk, there's 2 high risk and 5 medium risk. Well, I don't want that. There's a bit of, so I will just immediately scroll down to this table because I want to know what are these 5 and 2 and can I fix them? So let me sort by vulnerabilities, and then there are about 7 packages with a known vulnerability. So these are the ones that I need to fix. Usually fixing is pretty easy, but let's explore. So there's this dependency called Angular, and it has a lot of vulnerability issues. You can see in the middle, there's a large table of all kinds of vulnerabilities. But what you can also see is, well, this version is from 2018, so this hasn't been updated in years. So what I should do is update this version of Angular. It's currently, we are using 1.6, but I wanted to update it to 1.8.3, just updated to the latest version. And that typically already resolves most or all of these security issues. So as you can see, it's pretty easy to just quickly drill down into where are the security issues? Is there an update available? Yes, there is. And then here on the top right, it also shows you where this dependency is defined in the code base. So just go to that file, update your version of Angular, rerun Sigrid, and you should be good to go and have resolved this vulnerability. And then you just do that 7 times, and then you are done.
There is another question, Jan. My question might be a bit specific, but we need to do a CASA Tier 2 assessment for one of our mobile apps. I think Sigrid can help me with that. Does it say something to you, a CASA Tier 2?
I do not know what CASA is.
All right, maybe I can see if I can let you speak up, Nico, 1 second. If you want to. Allowed to talk. You should be able to talk.
Yes, I think so.
Yeah. Hello. Please
Yeah,
can you explain a bit?
yeah, the CASA tier two assessment that came to us when we wanted to do some health data out of our mobile apps, and they requested us to do this assessment. And yeah, it was a security assessment that's specifically addressed by Google. And we actually sent out a mail before, and they said that Sigrid might help us find the most security issues and how we can fix those. So I guess this should be, yeah, in some sort of a way that it's showing here.
Is this about security issues in your code or in your open
Yeah,
source?
in the code indeed.
Okay.
Yeah.
I think Sigrid can help there. So we'll go into the other Sigrid model, the security model next, and then we will show what it looks like. So
Okay, cool, thanks.
maybe that will answer your question.
Yeah.
Hopefully. There's another question coming in now. What is the advice slash suggestion in using Sigrid to do a proactive check on libraries? Is it before the library is in real use or after we already have pushed the code? I'm filling in some words here.
I would say it's a good practice before you start using a library to do a short sanity check, such as, popularity. Is this library, does it have millions of downloads? Then that's a good sign. Does the library have a large history of known vulnerabilities? Are there many and many? Then that's probably not a good sign.
Yeah, so an initial check it would be a good idea, and then following up with Sigrid to see what the actual current status of the different versions is.
Exactly. Many organizations, they have already defined what kind of open source licenses are acceptable or not. So you can check that beforehand. And then you can, once it's in Sigrid, you can double check whether you've done that correctly. But to be honest, the biggest part of open source is also keeping up to date. Like when you select a library, you always choose the latest version, and the latest version is almost always free of vulnerabilities. The thing is, in a month from now or 2 months from now, a vulnerability may appear, and then an update will be released, and you need to stay on top of that. So you need to keep coming back, making sure that the libraries are up to date and free of vulnerabilities. Because this list has 7 items today, but in a few months from now, there will be more known vulnerabilities. That's unfortunately how it goes. One more thing I wanted to point out, one more feature is there's this button here that says export bill of materials. So this is a big thing in some of these compliance regulations. It says you have to create a bill of materials. Now, this Cyclone DX, it's international standard that basically exports the list of all the open source you have, including are there vulnerabilities in there, what license there. And then you could import that in another compliance tool that you may have, if that's relevant for some organizations. Again, because they need to comply with certain rules, or they just want to have a central system to track it. You can do it. Sigrid can help you out. So Sigrid will create the inventory, and then you could either track the status of Sigrid yourself or do the export and track it in another tool. All this information can also be exported through the Sigrid API if that's your preference.
By the way, the API, some information on that you can find in the documentation, if I'm not mistaken, right? How this thing works.
Yes, definitely. If you want to know more about our API, there's this button on top, says documentation. Go there, and then you will find out how it works and find out how Sigrid works, because the documentation is pretty good nowadays.
Yeah.
All right. So we track some other metrics. I won't go in depth with all of them. I'll leave something to explore for you guys. So we covered vulnerabilities. We covered licenses. I won't go into details of what license is what. There is freshness, which says no. It says how long have you not updated. So for this system, freshness is pretty red. So that means that most libraries have not been updated in years. Which is, it's not an issue by itself, but it does mean that if you encounter a security issue in a library, then you need to process years of updates, which may take a lot of time. So while keeping this, I would say this should be more green, but it's less crucial than the first two items. And the other three metrics, they are more indicators of a quality library. They talk about, is there even a recent release? Is this a stable feature, a stable version, or is it a beta version? You know, those kind of things.
Jan, maybe a question from my side. Is there, you just briefly touched upon the objectives, also for open source health, obviously. Are there any guidelines or something that we can give to our customers as to what would be a good idea to work with?
Well, it really depends on your how much risk you're willing to run, because making changes costs money, of course, and it also depends on the profile of your application, right? Is it an internal application? Is it open to the internet, or is it only available to certain users? All these kind of things, they matter in terms of security, how much you're willing to accept.
Yeah. Can we track that information also in Sigrid about the type or importance of an application, or the age, or things like that?
You can, and I will get to that in a minute.
Okay.
It fits in the narrative of the security module.
All right.
Just general guidance. Like you should minimize the amount of vulnerabilities. That's very feasible. Just an update in 90% of the cases, the update itself is 5 minutes. I just update the version number. You may need to run your tests, depending on how automated your test suite is. But that's it, So there's rarely a good excuse to not update vulnerable libraries. It's my point of view.
Okay, thanks.
All right. I want to move to the security module unless there are open source specific questions at this time. They can always come later, of course. All right. Let's move on to software security. This is about inspecting your own code and identifying any possible implementation flaws there. So again, why do we care? Well, mostly it's similar to open source health. There's compliance, there's different regulations depending on your industry or where you're located that says you have to keep, pay attention to security, you have to do some kind of code scanning, you have to prevent security issues. And then you have to. Well, there's the security aspect itself, of course. You don't want to get hacked. That's what it's all about. If you read the news, there's articles in news all the time about leaked passwords or credit card details, that kind of stuff, right? It just costs money to any organization, and it also damages your reputation. I just, on this slide, I put the biggest example I could find. There's Okta. They are a software provider for identity management. They were hacked somewhere late last year, and as a result, so the news came out, and as a result, in the next day or couple of days, their stock value price dropped by $2 billion. That's a lot of money from a single security incident. Of course, their stock price, they did recover a little bit later, but yeah, that is no fun. I do want to say there is one upside about security. It's a very topic. There's a lot of information out there. So I've been doing this software security thing for about 10 years. And what I find is it's hard to know what the problem is. Right? Security is very complex. There are hundreds of things that can go wrong. Nobody knows all these hundreds of very specific security issues. But what I do find is that once you do know what the problem is, that is relatively easy in not all, but a lot of cases to address the issue. If someone tells you you have an issue and you have an issue here and the issue is called SQL injection, then you can go out there and it could be as simple as just Google how to prevent SQL injection in my programming language, in Java or whatever, and there will be resources that will tell you how to do that. Because there's so much been written about this. There's books, there's articles, there's e-learnings, there's everything is out there. But of course, first you have to know, do I have a problem? But once you do know, then there's many guidance out there. So this is why Sigrid focus on finding out are there problems, because that's the hard part of the whole security game. So let's go back to Sigrid.
Yeah, and this is also a nice bridge between what maintainability does when you find a security issue. If you have high maintainable code, then it's relatively easy to find and fix the issue that was found with the security module. So that brings the two things together.
So we're back to the Hadoop system. We're back to the overview page, and it says something scary about many critical findings. So let's dive in. So we are here. So let's say I am a developer. I'm tasked with figuring out what's wrong. Can we fix stuff? Let's see. So there are over 1,000 findings, which is very daunting. But I do have to say, Hadoop, this is a very large system. This is very old. So this is definitely above average. Going through all these items is a task. But let me see if there are some tips that would help you speed up going through all these items. But because assessing 1,300 items one by one, that's no fun. So how can Sigrid help you, figure out which of the findings are important? Well, it starts with risk, right? So there's high, medium, low, and critical. Of course, you start with the most critical ones and work your way down. Now, this is also where the type of application comes into play. So we have defined that the system is public facing. So that means it runs on the public internet, and that has an impact. If we would say this system is internal, it's only available via the internal network, so only your organization's user can access it, then the findings would be the same, but the risk associated with the findings would be much less, because there's only, instead of billions of people, there's only a couple thousand people maybe that can even access the system. So that just reduces the risk. So you can configure this in Sigrid, you can change the deployment type to internal, and then you would immediately see that the risk of these findings would drop. So instead of critical, this one might be medium or something else. How do we determine these risks? It's all based on benchmark data, right? There's a lot of information about historical vulnerabilities, and we benchmark that. So that's how we can figure out what would be the risk of this specific vulnerability in a public facing or in an internal system.
Before we move on to another topic, by the way, Jan, there's a question. Is this public facing, this deployment type thing, is that something that the customer fills in themselves in the metadata? Or is it something that we do?
This is what you fill in. This is part of the metadata of your system. Yeah, I think I actually go there. Yeah. So this is all the metadata, and somewhere here it says deployment type. You can say it's public facing, it's internal, it's something else. You can configure this in Sigrid, or you can also configure this in your code base and then upload it if you use Sigrid CI. There's multiple ways to populate this data, but it is provided by you as a Sigrid user. Okay. Having said that, these findings are right now, they are grouped, right? They're grouped according to the OWASP top 10. So you have a sort of category like access control. So you kind of know in what area are my vulnerabilities. You can slice and dice these findings any way you want. So I can say none, and then you just have a long list of findings. Or you can say I want to group them by components. So if you're a developer, you're working on just one component, you can, say, well, this is, I care about the common project, and then go there and see your findings. So there are many ways to slice and dice. So the findings are still the same, but it's just there's a way to make sense of the findings. The status overview, etc. Let's go back to this OWASP top 10. So let's say I for some reason I care about access control. Let's go there, and then there's this list. By default, I think it's sorted on the vulnerability, the severity. So it starts with these things that have a vulnerability severity of 8, and then there's only a few actually a high level, and then it drops to medium pretty quickly. So let's first take a look of an individual finding. Well, how do you look at an individual finding? Let's say this one is called path traversal. If we click on it, then you immediately go to the code base. You can see, well, apparently there's a finding in this specific line. It says path traversal, and it says this reads a file whose locations might be specified by user input. So if a user, you can specify a file and then the file is immediately being read. That's not awesome, because then if a user can specify this file, then they could read and potentially read any kind of file on your file system, which is not great. So, of course, you might have to do some additional analysis to figure out if this is an actual problem. You can trace where is this input file coming from. In this case, this input file, it comes from this command option. So we could, say it's actually user input, and then decide whether it's a problem or not. You could say this is user input, so that's a problem. You could also say, well, this is a command line tool, so it's not a problem because the user has access to these files anyway. It's a decision you make, right? The tool it tries to be smart in that it figures out, are there problems, but the tool is not all-knowing. So as a user, you may have more context than Sigrid. So you could decide, well, this is not a problem for our organization. You can say it's a false positive, or we accept the risk. Or you could decide this is something you want to change. You can say, well, I'm gonna fix this. You could decide, well, this says medium, but I actually think this is a huge problem for whatever reason. So you could change that. Save these changes. But what you could also do is you could go to the code explorer. Let's say if you decided I want to fix this, you could do is go to the code explorer, which is another Sigrid feature, and then you see it's highlighted the same finding, but in a different view. And then Sigrid will show you, well, there are actually other security findings in the same file. So might want to tackle those at the same time. I want to do all these three. Oh, and there's also maintainability issues in this file. Oh, there's this duplication issue. I'm also gonna, well, this is duplication in a piece, in a string that is kind of documentation, so I don't care about this one. Maybe they have other issues. Maybe I want to fix this issue while I'm here. And then add to the list. So you can sort of go around while you're here anyway. You might make some more changes. And here there's a list of all these things that I just selected, and there's a piece that you can just copy it into your Jira, your issue tracking system, so you can just create a ticket out of it. Anyway, this Sigrid Code Explorer is also a way to find security issues, right? Again, if you care about a specific part of your system, you care about this part, then you see, well, here in this part, there are 373 security issues, which again, you can look at. Again, this is the same data. The findings are the same as in the other module. It's just a different view on the same information. So you can use either the security module or you can use the code explorer module. The information is the same. The statuses, they are the same. It's all transfers back and forth. It's just whatever is your preference for your way of looking at things. There are multiple ways to identify issues in your system. So let me go back to the security module. One thing I typically like to do is go back. At some point, I like to group by finding type. And then you have all the findings of the same type, well, grouped. So I'm actually sort by severity. So we were just looking at something called path reversal. Find that. This one. So as you can see here, there are over 100 instances of path reversal in this system, potentially. So what I don't want to do is fix one of them and then fix the other next week. But what I could do is just look at all the path reversals in bulk, right? Because typically the same issue has the same solution. So you could decide this is a problem and then fix all the 100 issues in the same way, which is way more efficient than one by one. Or you could decide this is not a problem, and then you could just dismiss all the 100 issues at the same time, which is gets rid of a lot of noise. And that's way more efficient than going through each of these findings one by one. So even though there's 1,300 findings, actually over 300 of them are path reversal. So if you can solve this path reversal issue, you've already eliminated 300 out of your 1,300 issues. So even though the number seems high, it's actually, if you approach like this, it's more feasible than it may look at first glance.
I have a question here, Jan. It's about, do we have an example of a low-code OWASP finding or security finding? I did some searching in the platform, and the platform cloud demo system has findings. So maybe you can
sure
briefly go there as well, but we do have them.
I think at this point it's good to know that Sigrid security, it's backed by a lot of different analysis tools, security analysis tools. So for example, for this system Hadoop, there is 10 different security analysis tools that contribute to security findings. And what we as SIT do, we curate the findings from these tools to make sure that that's what we call useless findings that just contribute to noise, that they don't appear, that they are deduplicated. And yes, we also have analysis tools for low code. What was the name of the system again, Hugo?
Platform cloud demo. Yeah.
Platform cloud demo. This is a Mendix system. Yes, it is. Yeah. So just go to security, and if you go to origin, then you'll see there are we have some Mendix specific security rules that in this case were created by ourselves, and then there is another third-party tool called SemGraph that also has some findings. And this has really like, I'll be honest, I'm not a Mendix expert, but apparently this is a thing in Mendix, and I'll and Sigrid will highlight that for you.
Yeah, so if I may add a little bit to this, what we did for the Mendix security rules is that we worked together with Mendix to implement some of the Mendix best practices into the platform and measure that on the Mendix flows as well as on the Mendix configuration. And that second part is what you see here in Sigrid.
Of course, security best practices are specific per technology, per language. So for maintainability, we say we support all languages, and we do. There's way over 300. For security, that's a little bit less. We do support a lot of technologies, but not all of them. If you want to figure out, is my technology supported? Well, again, it's in the documentation. Yeah, that's about it. So using this security module, you can figure out where are the security findings, how many are there, how risky are they, and then you can use the grouping features to slice and dice these findings so you can address them more efficiently than just going one by one.
We got started now on the application level. Maybe if we go back to the portfolio overview, what are the things to actually slice and dice? We briefly touched upon the metadata, so maybe this is a nice angle to follow up on.
Yes. So if we go to portfolio level, we see this portfolio has a lot of systems in them, and Hadoop that we just use as demo is just one of those. So you can see here open source health. So you can see this is a very red looking portfolio. So they have some work to do, let's say, in terms of open source health, which is to be honest, we pick these systems because they're great for demo purposes because they have a lot of issues. Hopefully your own portfolio will be slightly less red. So you can see here, it's divided by team. So you can see how different teams in your organization are doing. But you could also choose this. Let's go to security. I haven't tried this to be honest, but let's see what happens. You can choose deployment type here, and then you can see different types. You can see like public. It goes from public facing to connected to internal to physical. That's more exposed to less exposed. I was hoping to see that the internal systems would have less criticality, but they don't in this case. But this also, if you care about your portfolio of a system, if you're like a CTO or CIO or enterprise architect, then you might want to know how are my systems doing, and this is how you can get that information.
All right, we've been talking for about 40 minutes or so. I don't know if there are any questions at this point. I think that most of it we've shown by now. Are there things you expected to be answered? Let me give you guys a bit of time to type if there's anything. And there is a question. So the question is, does it often happen that the open source libraries get less popular and maintenance by the community will stop over time? Then can Sigrid help detecting open source libraries that are no longer supported? There's a bit more, but there's the questions.
Yes, that's a great question, and it's actually one of my favorite topics. That happens all the time. So the thing with open source is it's maintained by someone, right? So there is someone who has a passion for a specific topic and then says, okay, I'm gonna develop this specific library because I need this specific library. An example that I was recently faced with was a library for creating PowerPoint documents in Python, which is something I happen to need. And then there was someone who also needed that and created this great library for doing that. So great, let's use this library, and it was great. Except then at some point a newer Python version came out, I think Python 3.10, and it broke. So it does not work. It did not work with Python 3.10, and the original developer was gone. He had other interests, so he wasn't developing it anymore. And it's not like someone can just take over, right? Because you need access to publish the dependency, and then that's a problem. There were people in the community willing to fix the issue, but they didn't have access to publish a new version. So that happens all the time. Some dependencies, they are maintained by large organizations, but a lot of them just individuals. Now, and sometimes they just that happens. But to answer the question, let's go back to Hadoop. Can Sigrid figure this out? Kind of. We have this metric called where is it? Activity, all the way on the right. And activity says when was the last release. So I'll just sort by risk. So for example, these are medium risk, so they are definitely already kind of risky. So you could see for this dependency, the last release was in 2019. So that is almost 5 years ago. So if there has been no release in 5 years, then I'm gonna almost guarantee you there will not be any release. So that means this is inactive. So this is how Sigrid can help you identify these kind of inactive, unmaintained libraries. And it is a problem. The more dependencies are there, the more that get abandoned. And then if a vulnerability appears, you just have to hope that the original developer comes out of the woodworks and helps you fix them. Because otherwise, you just have to abandon it and make your own copy, make your own fork of it, or hope that somebody else does.
And once you start changing that library, or maybe take it into your own maintenance scope, you can measure it using the Sigrid security module again. Is it?
Yeah, so open source is great. Use it all the time, but do know that at some point you may need to make these changes, right? Because it's free, as in you don't pay money, but it's not free, as in you still need to do maintenance and maybe at some point swap out the library if the situation is not maintained anymore. Yeah.
All right. I've not seen any more questions at this point, but there is one now. So there's another question coming in. As a Mendix uses microflows for business logic, how can we identify duplicates in code or unit size or complexity? I think that's more of a maintainability question, isn't it? So what I would say, if I may answer that question, Jan, if we're looking at Mendix or at code in general, there is for a maintainability perspective, we measure duplication per lines for regular line-based code, and for Mendix we look, or for low code in general, but for Mendix as well, we do look at the number of activities. So the activities that you see on your screen, we can compare to other activities and then see what the duplication is, how many activities there are in one flow, also deciding on the size and the complexity of it. So how many decision points there are in the flow. It's very similar between the different technologies, low code and high code technologies, but yeah, well, we do measure it in this way. If you want to know more about that, there's a bit more information also in the documentation, and I can reach out to you as well later on. I think that that would help. I'll make sure to contact you.
All right. So I think it's good at this point to also point out we are, as SIG, as Sigrid, we're always working on improving Sigrid. So improving our open source health module. I know we are thinking about things like benchmarking, figuring out, okay, this is the state of the system in terms of inactive and old libraries, but how do we actually compare to the market? That's something we don't have right now, but that's something we likely will have in the future. In terms of code security, we're also always looking at adding new scanners for new technologies to get a broader coverage. So this is the Sigrid open source health and security that you see today. But if you come back in a few months, I bet there will be some feature announcement. It's definitely something we are working on all the time.
If there are any questions or suggestions about tools or maybe frameworks or anything, is there a way to get in contact with us?
I would say yes, but I would also say get in contact with your customer success manager.
Yeah.
So I guess you know better than me.
Yeah, I would also suggest that indeed. Just get in contact with your CSM, your customer success manager, if there's any security model that you miss or any tool that you may already use and that we apparently don't. although we have a lot. We would be happy to hear from you.
And if you don't know who that is, or you don't have an email address or a phone number, there's always this neat button with a question mark on top. And then you can say, I have a feature request or bug request, and you can fill out this form, and it will also end up in the right place.
Okay, I have one more question about security, and this is, what's the difference between accepting or ignoring a risk or any of the other actions available? It's on the process side, obviously.
So let's go there. So there are different statuses, right? Then you pick a random finding. There are these 6 statuses. The difference is it's more about how you want to define your own internal process, right? Every finding starts out as raw, which means it is identified by the tool, but you as a user has not yet assessed the finding. And the other statuses, they are for you to be used however you see fit. So what I like to do is say will fix if I want to fix it, false positive if I think it's not. This is not even a problem at all. The tool is just wrong. And risk accepted would mean this is a problem, but I think the problem is not big enough, so I'm not going to fix it. And then well, fixed is obvious. And what did we miss? Refined, that would mean I have added some information to this finding. I did some analysis, and then maybe you can write down the results of our analysis in the remarks, but no decision has been made yet to this finding. That's the idea, but in the end, you can define your own own process. You can define these statuses as you see fit. The only impact that it does have, if you say it's accepted, fixed, or false positive, then a finding will be removed from the default view. So right now there are 1,300 findings. If for 100 of them I say they are fixed, false positive, or accepted, then this number will drop, because we call those resolved findings, and they don't show up.
Will these findings stay like resolved or away even if you have a new code upload or a new scan?
Yes. So if there's a certain finding in a certain file that you said this is a false positive, it will stay a false positive. It will be annoying if you have to do that every day when new code comes in.
Yeah, indeed.
I always like to mention our that I almost forgot because it's hidden. Our filter option, which has been hidden out of the way here, which also allows you to slice and dice these findings. Right? Like I said, by default, it hides the resolved findings, but I can actually unhide them. So for example, if I click this button, then it will only show the result findings, of which there are none at this point. Or we can say, I only want findings that I say, I will fix these findings. And then we find our one issue that I just put to will fix 10 minutes ago. So just be aware, filters. These filters are pretty neat. But you have to find this button first. But now you guys found it. So.
Right, there's one more question. They keep coming in, which is nice. We are nearing the end. I think this would be the last question before I round up. It's about what is the best way to get a tallied number to see how many items have been resolved over a particular period of time. Is there some kind of overview that you can see the line going up or down, or how would you do that?
On a system level, I would do what I just said. So you can select the time period. So I've selected year to date, and then just go to resolved. Well, in this case, it's 0, so that's disappointing, but they will pop up here. And on a portfolio level, security. There we have this very big table that takes a while to load, and you also see these numbers here in green and red. So, for example, with Hadoop system, in this specific time period, 16 new findings were introduced, and 8 of them were removed. likely by code changes or code being removed.
Yeah, and something similar works for the open source health portfolio overview and the maintainability portfolio overview, right? Where you can see numbers going up or down.
Yes.
All right. All right. We have 5 more minutes left. I have a few more slides that I want to show. So I'll take over your screen, Jan. I can do that. And I will start with a short and brief wrap up. So we talked about security and open source health. There is more information, as we briefly hinted upon already. If you want to know more about, for example, system level security, I have a QR code here on the left, or portfolio level open source health. We just saw that on screen just yet. And there are some frequently asked questions about security. There also is a particular page on the documentation. These are just 3, well, not fairly random picked pages, but there's way more information you can see on docs.sigrid-says.com. So there's way more information that you can get from there. What we did today is more or less the same as what we did last time, and this time about a different topic, obviously, but we recorded the session as well. We will make sure that it will be available on YouTube in one way or the other. We have a few of them already available. For example, last time we were talking about the portfolio objectives. So where we briefly touched upon the objectives with the gold cup or the gray cup, there's way more information about that with the PO of that topic, talking about that last time. So please do go there. You can Google or search for it, Sigrid Ask Me Anything sessions, or just scan the QR code here on the screen. Then looking forward, up next, there will be again another Ask Me Anything session, and the next one will be about how to set up Sigrid. So it's a bit more basic, but we were going to talk about, for example, how to do scoping yourself, how to make sure what Sigrid measures and what Sigrid doesn't measure, how to group your systems into different parts, how to set up the metadata, how to set up your Sigrid CI, everything together. This is going to be April 25, so in 2 months from now. Again, at 3 p.m. Central European Summer Time in this case, or 9 a.m. Eastern Time. You can sign up here on the left-hand side. You can also search for Sigrid Ask Me Anything and find it on Google. With that said, I want to thank you for today. Thank you for all of your questions. It has been a very nice and interactive session. I hope we answered all or most of your questions. I will follow up with a few open questions that are still there, and I hope to see you next time. Thank you.